This is mixed exercise 11.04 on integration, A-level, pure maths, year 2. We've got 3 questions. Question 1. Find the integral of x cos 2x dx. B. Hence, using a suitable trigonometric identity, find the integral of x sine squared x dx. So for A, we're going to use integration by parts. And the formula for integration by parts is given by integral of u dv is equals to uv minus integral of v du. So for this one here, x cos 2x dx, let du equals to x, and therefore dv will be equals to cos 2x dx. And so du will be equals to dx, or 1 dx. And then v will be equals to the integral of cos 2x dx. This will evaluate to be sine 2x multiplied by half. So doing the substitution in the formula, integral of u dv equals to uv minus integral of v du. We have our u to be x, which is here, and our dv to be that. So this will give me the integral I'm looking for, this one here. So I have the integral of x cos 2x dx is equals to uv. U is there and v is here. So I'll have half x sine 2x minus v du will be half sine x times dx. So I'll have the integral of half sine 2x dx. And so that will give me half x sine 2x minus half times, if I integrate sine 2x, I'll get half cos 2x, but it will be negative. So this will change to plus and add my integration constant. So if I simplify that, I'm going to get half x sine 2x plus 1/4 cos 2x plus c. And that is the answer for A. So for B, we are told to find the integral of x sine squared x dx using a suitable trig identity. Now the trig identity I'm going to use will be cos 2x is equals to 1 minus 2 sine squared x. So from here, if I make 2 sine squared the subject, I will get 2 sine squared x is equals to 1 minus cos 2x. Then I'll divide both sides by 2, and I have sine squared x is equals to 1/2 brackets 1 minus cos 2x. So my integration of x sine squared x dx becomes the integral of x, which is this one, and I'm going to replace the sine squared x with the whole of that. So I get times half bracket 1 minus cos 2x dx. Now I'm going to simplify this side, and I'm going to get the integral of x sine squared x dx will be equal to half integral of x 1 minus cos 2x dx. Now I'll further simplify that to get the following. Half integral of x dx minus integral of x cos 2x dx. I can now proceed to integrate, and I'm going to get, I'll still leave the half outside, half, and if I integrate x, I'm going to get half x squared minus. Now remember that we have already integrated x cos 2x in part A, and that is the integral we obtained. So we can just substitute the whole of that with that. And so I'm going to do that now. I'm going to get minus brackets half x sine 2x plus a quarter cos 2x. And finally, if I expand that, I'm going to get 1/4 x squared, and that will be this times that. And then I'll have minus 1/4 x sine 2x minus 1/8 cos 2x. And then I add my final integration constant, c. And so that's the final answer. Question 2. Find the values of a for which the integral of x plus a half with respect to x between the limits of 1 and a will be equal to the integral of 2 sec squared x dx between the limits of 0 and pi over 4. So I have got integral of x plus a half with respect to x between the limits of 1 and a equal to 2 times the integral of sec squared x dx. And the limits will be 0 and pi over 4. So if I integrate x with respect to x, I'll get half x squared plus half x, and that's the integration of half. And I put in my limits from 1 to a. And on the right hand side, I have 2. Then I'll integrate sec squared x. I'll get tan x. I'll put my limits again from 0 to pi on 4. First, I'll simplify this by bringing half out to get the following. So x squared here plus x. The limit will be 1 and a here equals to 2 and tan x with the same limits. I can take the half to this side and I'll get x squared plus x between the same limits equals to 4 times tan x. I can now do my substitution to get the following. A squared plus a, all of that minus 1 plus 1. So I put 1 here, I get 1, and I put 1 here, I get 1. That is equal to 4 brackets tan pi on 4 minus tan 0. Then if I evaluate this, I'm going to get a squared plus a minus 2 is equals to 4 brackets. Tan pi over 4 is 1 and tan 0 is 0. So simplify that, I'll get a squared minus a minus 2 minus 4 is equals to 0. And that means a squared minus a minus 6 equals to 0. If I factorize that, I'm going to get a minus 3 and a plus 2 equals to 0. So it means that the values I'm looking for are a is equals to 3 and a is equals to minus 2. So these are the two answers required for A. Question 3. F of x is equal to 2x plus 15 all over x minus 1 times x plus 2 for values of x bigger than 1. A. Express f of x in partial fractions. B. Find the integral of f of x with respect to x between the limits of 2 and 3, giving your answer in the form ln k, where k is a rational constant. So f of x is 3x plus 15, all of that, over x minus 1 times x plus 2 will be equals to some constant a over x minus 1 plus another constant b over x plus 2. How would I multiply the three terms by the denominator of the left-hand side? So if I do that, I'm going to get 3x plus 15. This should be 15. 3x plus 15 equal to a times x plus 2 plus b times x minus 1. Then when x is equals to 1, the whole of this term becomes 0, and the left hand side will be 3 plus 15, and that will be 18. So I have 18 is equal to 3a, which implies that a is equals to 18 over 3, which is equals to 6. In the same way, when x is equals to minus 2, the left-hand side will be minus 6 plus 15 equals to, and that will be 0. And then I will have minus 3 in the brackets times b, and I get minus 3b. So that means I'll get 9 is equals to minus 3b, which implies that b is equals to 9 over minus 3, which will be minus 3. So b is minus 3. F of x can therefore be written as 6 over x minus 1 minus 3 over x plus 2. And that's the answer for A. So for B, the integral of f of x between the limits of 2 and 3 will therefore be equal to the integral of 6 over x minus 1 minus 3 over x plus 2 dx from 2 to 3. So if I integrate, I'm going to get 6 ln x minus 1, all of that between the limits of 2 and 3, minus 3 ln x plus 2, again, all of that between the limits of 2 and 3. So I'm going to do my substitution. I'm going to get 6 ln 2 minus ln 1, because if I put 3 here, I'm going to get 3 minus 1, that's 2, minus, and I put 2 inside here, I'm going to get 2 minus 1, that is ln 1, and then I'll have minus, doing the same thing for this term, get 3 brackets ln 5 minus ln 4. Then I'll simplify this, and I'm going to get 6 ln 2, but ln 1 is 0, so I have minus 3 times that will give me 3 ln 5, and then minus times minus ln 4 will give plus 3 ln 4. That will be equal to, and using the laws of logs, I'll get ln 2 to the power 6 minus ln 5 to the power 3 plus ln 4 to the power 3. And using the laws of logs again, I'm going to get log 2 to the power 6 times 4 to the power 3, all of that over 5 to the power 3. Then if I evaluate this, I'm going to get ln brackets 4096 over 125. And this is the answer required. And this brings us to the end of the session on integration, mixed exercise 11.04.